We've talked about zeros before, and we're going to talk about them a little bit more here today and in the future, very near future, a little more about them. But just remind me or help me recall here, what do we mean by the zero of a function?
Setting it equal to zero? Or
Yeah, it's the function value equals zero, okay? So it's the x value where f of x equals zero, right? You solve it. You set f of x equal to zero and you solve it for the x value. There may be more than one, right? We've got f of x equals x squared minus x minus 6. And I want the zeros of that function. Yeah, just set f of x equals 0. It's just solving the equation there. Now, in this particular case, you use factoring, use quadratic formula. Doesn't matter, I guess, a whole lot, but easy enough to factor. Minus 3 plus 2 be the factoring, and so, yeah, this one's going to have two zeros. The solutions to those two, which add 3, you got x is 3, and then subtract 2. Okay, so those are the zeros for this function. All right. Now, if I have f of x equals x to the fourth minus 15x squared, one particular note about this one is, again, talk about the zeros. Set f of x equal to 0, solve the equation. But the reason I mentioned this one is, okay, so that one, set it equal to 0, factors off an x squared, set x squared equal to 0, and x squared minus 15 equal to 0. Of course, here, square root both sides, you got x is 0. And then over here, you got x squared, add the 15, and then square root both sides. But you got plus or minus. But the main thing I wanted to mention on this one is, it's the same sort of idea, is this one right here. Because technically, that 0 occurs twice, doesn't it? Because it's x squared equals 0. You can think of it, we didn't,
The square root of 0.
it's the square root of 0, you can think of it that way. Or you can think of, it's x squared, so it's x times x, and so technically there's, if I set both of those equal to 0, there's two of those, all right? So what I'm saying here is this 0 is a little different than these zeros because it occurs twice. Okay, and so that is what I wanted to bring up here. That's called a multiplicity. 0 here, because it occurs twice, you've got x squared equals 0, so it's going to occur twice. This one has a multiplicity of 2. Multiplicity of 2. So when you have similar things, now this one, you got square root of 15, and I guess I could write it out, and negative square root of 15. And so those just occur once, right? There's one of those and there's one of those. But this 0, the 0 that is 0, has a multiplicity of 2, and it's because, it occurs twice. And we'll see some more that particular thing happens with here in just a second. Okay? Now, the ones on this assignment may not look quite like this. Matter of fact, they may start out already factored, but it's still a similar process. It's that you actually don't even have to factor it, but the deal is we'll be concerned about this multiplicity. They'll ask us about multiplicity, give the zeros and the multiplicity. So that's what we're going to do here in these next couple of problems. All right, so here's Find the zeros and their multiplicities. Oh, before I move on to that, one thing that the multiplicity tells us about, actually, we graphed this last time we were here. We graphed that, and if you recall, so we recall the graph here, it looks like this. You know, we did a whole lot more work, but it wound up looking like this. And why I bring this up is because this kind of highlights one thing the multiplicity tells us. Because this zero of 0 had a multiplicity of 2, you notice here, you know, these zeros, the real zeros, are x-intercepts on the graph. Why is that? Because the y is 0. Yeah, so they're x-intercepts on the graph, and so this one's the negative square root of 15, and this was the positive square root of 15, and this was the 0 of 0. Those are x-intercepts, but you see a difference between the 0 here of 0 and then the square root of 15 and the negative square root of 15. With this multiplicity of 2, we had that turnaround at the x-axis instead of at the negative square root of 15 and positive. It went through the graph. Okay, so that's one thing the multiplicity can tell you. If it's an even multiplicity, you're going to have one of these turnaround at your x-intercepts. Okay, but that's just kind of a side note. But I wanted to mention that. Now, on back to this one. Find the zeros and their multiplicities. So this first one is f of x equals 4x cubed times x minus 1 squared times 3x plus 12 to our fourth power. Yeah, so you can see why they already factored this, because if we factored this on our own, it would take a while to get that factored. But all we want to do here is find the zeros and their multiplicities. That's all I want us to do. Well, since it's already factored, setting this equal to 0, how am I going to get those zeros? Well, since it's already factored, I can just set each one of them equal to 0. But even better yet, all right, so if 4x squared equals 0, what does x need to be there?
0.
It's going to be 0, okay? Now, so you divide by 4 and all that, but it's got to be x is 0. With me there? Now, it does have a multiplicity. What multiplicity does it, based on our previous discussion on that problem? What's the multiplicity of this one?
3 times.
It's 3, yeah. You got x cubed, and so 0 occurs 3 times there. So it's got a multiplicity of 3. All right, so you see how this is going to work?
Mm-hmm.
Now, on this one, what about this one?
No more choosing.
I'm going to have x minus 1 equals 0, isn't it? I've got x minus 1 squared, essentially square rooting both sides. But yeah, it's just going to mean if I've got x minus 1 squared equals 0, then x minus 1 has to equal 0. And so what's the 0 there? Positive 1, because you add 1. But what's the multiplicity? Multiplicity of 2, yeah. Because it's a square. It occurs twice. I mean, you don't have to write it out twice, but that's technically what we could do. Like I said, it's x minus 1 times x minus 1. And then I'd have x minus 1 equals 0, x minus 1 equals 0. But you don't have to do that. Just solve it once and just say you got a multiplicity of 2. Same here. 3x plus 12 must equal 0.
3x.
So 3x equals negative 12. Subtract the 12.
Divided by 3, which
Divide by 3.
x equals negative 4.
X equals negative. Yeah. So it may be a little more solving you'd have to do there, but same idea. Now what multiplicity does it have?
4.
Yeah, technically, that's there 4 times, and so it's a multiplicity of 4.
So when you're doing the breakdown, you're taking off that exponent all the way, and then you add it to the bottom of how many?
Yeah, the exponent tells you how many you have, yeah. Because like I said, I could write that out 4 times, but it'd be the same 4 equations. No need to do that, okay? Just say it's a 0 of -4, and the multiplicity is 4. Okay?
So the exponent is going to be the multiplicity, basically.
The exponent gives you the multiplicity. Yes, sir. All right. What about this one? What are the zeros and the multiplicities of this one? F of x equals 1/3 times x plus 3 to the 5th times x squared plus 7. I mentioned this one for a couple of reasons. First reason is, okay, so we're trying to find the zeros and their multiplicities. It's already factored. The first reason I mentioned this one is, what about that 1/3 there? Well, I could, if you want to be technical, I guess, we can set it equal to 0, but does that make any sense?
No.
It doesn't have an x with it. So 1/3 cannot equal 0. So if you don't have an x with this number here, that's not going to give you a 0, because you got 1/3 equals 0. That doesn't make any sense, okay? So if it's just a number in front, that's not going to give you anything. Like this one, I had 4x cubed, but it was with x cubed, so that's why I got something out of that. All right, so then what about the other zeros? Well, same thing here, right? X plus 3 equals 0. Subtract 3, you got x is -3, but it's to the 5th power, and so you got a multiplicity of 5. And then this last one, so set it equal to 0. So what have I got there? X squared equals -7. And so x would equal plus or minus the square root of -7, which is I times the square root of 7, right? Because you got the square root of -1. Square root of -1 is I. With me there? Now, again, this is different than this because I didn't write it, but this I have x plus 3 to the 5th power. So I've got 5 different factors of x plus 3 out there. I don't have multiple factors of this one, do I?
No.
So those don't have a multiplicity, or I guess you could say multiplicity 1, but those won't have multiple occurrences. They're just, that's it. That's, you got one of those and one of these. Those just occur one time. There's not a multiplicity of those. So, you know, we said the power tells you the multiplicity, but that's only if you have something like this.
It's outside of the
Binomial, yeah, outside, or, I mean, with x, you got that, but, okay. Any other questions on that?
What happens to the 1/3?
The 1/3, it just doesn't give you any 0.
So it just drops off.
It just kind of, as far as this problem is concerned, yeah, it just falls out. All right. Now, there is a linkage here that I want us to note. Let's go back to the zeros. So f of x equals x squared minus x minus 6. First one we started with. The zeros were, well, it factored as x minus 3 times x plus 2. And then the zeros were positive 3 and negative 2. Right? With me there. That's one we did, just the first one we did. Well, notice this linkage here. If I have, if x minus k, let's say, is a factor of f, if x minus a number is a factor of f, then what is a zero? Well, here's an example, what I'm going for here. So we got x minus 3 is a factor, and what was the zero? Positive 3. X minus 3 was a factor, 3 is a zero. So if x minus k is a factor, what's a zero? K. Yeah? X minus k is a factor, k is a zero. Now, on this particular one, I mean, we could make a similar observation here. If x plus k is a factor, then what is a zero? Negative k. So how does this work? Well, it's kind of, we've seen this before. X minus k, so k, the opposite, if you will, of what appears here. Kind of move the right and left shifting. You know, remember we had to do the opposite of what we thought. Sort of a similar idea. X minus k is a factor, k is a zero. So it's positive k. X plus k, negative k is a zero. Okay? All right. Now, that's really, here's what I'm really going for. It works the other way too, doesn't it? If k is a zero, then what's a factor?
X minus k.
X minus k, yeah. It works the other way too, doesn't it? Because if I have this as zero, then I can automatically say that's a factor. That's really what I'm going for here because of what we're going to do next. If minus k is a zero, it's really saying the same thing, but then x plus k is a factor. So the converse works too. And that's really what we're going to need here for the next round of problems here that I'm going to talk about. So we're going to use, you with me there? Any question about that? Is that okay? All right, well, so here's what I'm going to do with that. Find a polynomial function. Number one, with zeros, 0, 2, and negative 6. Find a polynomial function with 0, 0, 2, and negative 6. So essentially, what we're doing here is just the reverse of what we were doing on the previous problems. Previous problems I was saying, here's the function, find the zeros. Now I'm saying, here's the zeros, find the function. But it's very much what we're going to do is use this fact here. All right. So, 0, 2, and negative 6. Let's start with the 2 here. So what these give me, those give me the factors, right? If those are zeros, then don't I know the factors of this polynomial function? Okay. All right, well, let's start with the 2. If 2 is a 0, then what's a factor? X minus 2. If negative 6 is a factor, then what? A 0, what's a factor? X plus 6. So it's just the opposite of what appears there, right? 2, so you go x minus 2. Negative 6, so we go x plus 6. Now, 0, kind of a, I mean, yeah, you could say x minus 0, but is that minus 0 really necessary? Yeah, if your 0 is 0, then it's just x here, isn't it? Because x minus 0 would be still just x. Okay? We good there? Now, the way they'll want that is they do want it multiplied out. And so we're just going to FOIL and then distribute. I mean, you can distribute and then FOIL, but I would go ahead and FOIL. First of all, if you got two binomials, FOIL that out. Then we'll distribute the x. So that'd be x times x is x squared. X times 6 is plus 6x. Minus 2 times x is minus 2x. Minus 2 times negative 6, minus 2 times positive 6 is 12. So we got x squared plus 4x minus 12. Parentheses. Okay? Now we distribute
Another x.
another x, yeah. So x times x squared is x cubed. X times 4x is 4x squared. And then x times negative 12 is negative 12x. Okay? So the second one on this one I'll do, find a polynomial function with zeros. 4 with multiplicity of 2 and negative 1. So I'll throw in a little twist there. Well, okay, so if it's, we got a 0 of 4, what's the factor? X minus 4.
Times
Now,
squared.
if it's a multiplicity of 2, what does that tell me? That tells me the power, doesn't it? And so if I've got a multiplicity of 2, it's x minus 4 squared. And then the minus 1, that would be
Plus 1.
x plus 1. All right, so again, if you want that, square it out. Write it out twice, so that'd be x squared minus 4x minus another 4x plus 16 times x plus 1, so that's x squared minus 8x plus 16. All right, you combine the two in the middle, times x plus 1. And so that's, the way I do it, just go ahead and multiply the x squared times the x and the 1, so it'll be x cubed plus x squared. Then do the minus 8x, so it'll be minus 8x squared minus 8x. And then do the 16, so it'll be plus 16x plus 16. And so you wind up with f of x equals x cubed minus 7x squared plus 8x plus 16. Question? Is that okay? Now one more tie in here. Let's call it 2a. All right, so same thing, zeros, same zeros, but also with f of 3 equal 10. F of 3 equals 10. Well, this is, all right, so on the previous two, on this one and then number 1, I didn't have any other stipulation. So really, if you think about it, this is just one possibility of having zeros 4 with multiplicity 2 and negative 1. All right? That's just one possibility because as long as I have those two factors, and that one squared, we've got this thing with those zeros. However, couldn't I add right here, go back to this, couldn't I add any number I wanted right there? I could add a 3 or a 2 or a 5. It would still have those zeros, wouldn't it? And the reason I would do that is because if I wanted to hit a specific point, is what I'm getting at here. So if I had this extra part to it, what I have to do, so yeah, I have f of x equals, same zero, so I got zeros of 4, so I'd have x minus 4, multiplicity 2, so that'd be squared, and then x plus 1 for the negative 1. But to hit this thing, I've got to add an a in front, which we've done that a couple of times, right? Ax squared plus b, same a. I'm going to have to factor in an a here. And I'm going to have to figure out, based on those given information, what a is. Now, how could I figure out what I need the a here to be based on these? What would I do? What does this give me?
That gives
What's the
you
3?
0. Well, 5.
That gives me an x, and the 10 is the y, or f of x. Yeah, so this is the input, so that's the x, that's the y, but in this particular case, we're calling it f of x, right? Y is f of x. Yeah, so I just plug in 3 for x, 10 for y, add this little a right here. I didn't have to use it here because it didn't specify. But with this point, to get this point, I'm going to have to do that. All right, so 10 equals, all right, so a times the x is, and you know, you can add it there or use this one. Let's use this one. All right, so 3 minus 4 squared is 3 plus 1. Yeah, so we plugged in x to be 3 and the f of x to be 10. What does that give me? Well, negative 1 squared is positive 1 times 4, so that's just 10 equals a times 4. How do you get rid of the 4? Divide it. 75. That reduces 5 halves, 2.5. So my final answer, if I had a specific value, function value in mind, I'd put that a to be 5 halves in front. Okay? That would be our final answer, and then like I said, if you needed to, you could multiply those out again and then distribute.
Oh, okay, I see what I did wrong.
But we'll just leave it there. All right?